Hello friends, in this video we are going to discuss what will be the perfect temperature to operate a p-type and a n-type semiconductor. So for that case, let us first discuss about the n-type semiconductor. So in an n-type semiconductor, we know when the conductivity is minimum, at that case the electron concentration, that is the value of small n, is equals to Ni root over mu of P, that is the mobility of the holes, and mu of n, that is the mobility of the electrons. Now similarly, we can find the value of hole concentration in the n-type material when the conductivity is minimum, which will be equals to Ni root over mu n divided by mu p. Next, since it is a n-type semiconductor, so we can say that the electron concentration inside the n-type semiconductor, we know that it must be greater than the intrinsic carrier concentration Ni. Now, from these two equations, that is Ni root over mu p by mu n, and the equation of hole concentration Ni root over mu n by mu p, we can know that for a semiconductor, we know that the mobility value of the electron, that is mu n, is greater than the mobility value of the hole. So if the mobility value of the electron is greater than the mobility value of the hole, then we can say that from this equation of n, we can say that the n value will be less than the Ni value, because this mu p value is less than the mu n value. So we can say that the electron concentration n will be less than the Ni value. Similarly, from the p equation, using the information of mu n greater than mu p, we can write that the hole concentration will be greater than Ni value. So if we look at these two conclusions, that P, that is the hole concentration, is greater than Ni and electron concentration is less than Ni. But for the n-type material, we know that the electron concentration should be greater than Ni. So we can say these two conclusion is contradictory for n-type semiconductor, because in an n-type semiconductor the electron concentration must be greater than Ni and the hole concentration must less than Ni. But we have found from minimum conductivity condition our Ni value is less than Ni, but the electron value or the electron concentration is less than Ni and the hole concentration value is greater than Ni. So this is a contradictory to the n-type semiconductor fact. So from this total calculation, we can say a very important conclusion. The conclusion is that when sigma value is minimum in n-type semiconductor, at that case the entire semiconductor will start behaving as p-type semiconductor, because at minimum conductivity we have seen that the n value that we have found will be less than ni, and the p value is greater than ni, and this only happens inside a p-type semiconductor. So we can say that if the conductivity value is minimum in a n-type semiconductor, then the entire semiconductor will start behaving as a p-type semiconductor, and the donor concentration, that is the nd value, will be negative. So this is a very important conclusion that we can draw for a n-type semiconductor at minimum conductivity condition, and it states that if we make the conductivity of a n-type semiconductor minimum, then the entire semiconductor which was n-type will start behaving as a p-type semiconductor, because the donor concentration Nd will become negative. Now this is all about the n-type semiconductor. Now let us discuss about the p-type semiconductor. For that case, let us consider a p-type semiconductor. So for a p-type semiconductor, we know that the hole concentration, that is small p, should be greater than the Ni value, and the electron concentration inside the p-type semiconductor will be less than Ni value. This is for p-type semiconductor. We know that. Now we will apply the conductivity minimum condition. That means when the conductivity value will be sigma minimum, that is the minimum conductivity, we know that the whole concentration of the p-type semiconductor can be written as Ni root over mu n divided by mu p, and the electron concentration n can be written as Ni root over mu p divided by mu n. And from general semiconductor physics, we know that the mobility value of the holes is less than the mobility value of the electrons. So if we use this conclusion in the p equation and n equation, then we can write that this p value will be greater than the Ni, and from this equation of n we can write that n value should be less than Ni. Now we can see that from these two equations the whole concentration will be greater than the Ni, and the electron concentration will be less than the Ni. And this also holds for the p-type semiconductor. P is greater than Ni and N is less than Ni. So we can say that an important conclusion can be drawn here, in the case of p-type semiconductor, that is when the conductivity, that is sigma, will be minimum. At that case, in p-type semiconductor, then the p-type material will behave as p-type. It will remain p-type, and the acceptor concentration, that is Na, will be positive. But when we have discussed this thing in the n-type semiconductor, we have found that for minimum conductivity value, the n-type semiconductor has converted into p-type semiconductor. But in this p-type, the p-type remains as p-type on minimum conductivity. So we can say right now that the minimum conductivity value sigma occurs at will be around 400K. So if we operate a n-type semiconductor device at 400K, then this n-type semiconductor device will be converted into p-type semiconductor, because at 400K the conductivity value is minimum. Similarly, if we use a p-type semiconductor device at 400K, then the p-type semiconductor device will operate as p-type semiconductor device. There is no change. But the n-type semiconductor device will behave as a p-type semiconductor device. That means we can say that all the device must be operated below 400K. If this is not maintained, then at 400K all the n-type devices will be behaving as a p-type device, which is not desirable. That's why generally all the semiconductor devices are operated below temperature equals to 400K. So in this way we can find the operating temperature of an n-type device or a p-type device. Thank you.